Okay, guys, today is going to be a review session. As I said, the second thing I'm going to do is go through a practice problem. Monica emailed me and suggested that that would be helpful, and I think that would be helpful to a lot of people. What will make it particularly helpful is if while I send it around, while I'm getting the outline up and getting myself organized, start setting it up. Start working on it yourself. Pretend that you're in the exam. See how quickly you can start translating this into a game, okay? That'll really help us make the best use of this. Thanks, June. He's here.
Professor, is each problem on the exam going to be like this format? Like a big question, because like on your grading sheet it says question 1, 2, 3, 4. So they all big questions like this.
I think I know what you're asking. I'll say a little bit more in a second. Grab one of those for myself. Are there extras of the problem? I didn't grab one for myself. There must be. Oh, terrific, right here. Thank you. That's great. Okay, I'm seeing enough people looking up that I am going to go ahead and start talking. If you think your time is best spent cranking away on that problem, keep working, it's fine. I won't be offended. I will repeat some things right now and say some new things as well about the test format and about logistics. Okay, so one question I had a second ago was Elaine asked, is the format of the test going to be like this question? Yes. And specifically, it's going to be like this question in the sense that it'll be a scenario with a set of questions. There'll be changes to the scenario with other sets of questions. Okay, so there are going to be 4 questions like that on the exam. 4 stories that you will have to translate into a game, say some things about the baseline version of the game, make some changes, see what happens, analyze the new game, and interpret your answers. Okay? So that's generally what you're going to be doing. What will be different on the final than from the midterm is that you don't need to bring blue books. Okay, so the final exam sheets are not going to look like this with all the words put together. There's going to be space for you to do your work right on the exam sheet. Okay, if you find yourself during the exam, you've made a mistake, you're writing in pen, we'll have some extra copies. It's also fine if you want to bring your own sheets of paper if you need to attach supplemental sheets. That's not a problem. Okay, the idea of giving you the space to do the exam right on the page is mainly just to simplify things for us. Okay. Other logistical point that I want to re-emphasize is the rooms. So as I said, on Tuesday, if you are in Adam or Emily's sections, you'll take the exam here, right? I said you guys would be here, and June and Flory would be in the other room. Okay, here it says Haynes 118. If you are in June or Flory's sections, I'd like you to go to Perloff 1102. So we'll have more space. Okay, it's not going to be as crowded as it was during the midterm, and that's good for everybody. The exam starts at 3 p.m. Be there on time, okay? It starts at 3 p.m. whether you're in the room or not, and ends at 6 p.m. No books or notes. I think I said this before the midterm, but I'm not sure, and even if I did, it probably bears repeating. Something I would recommend you do late in your studying process is to make yourself a summary sheet, okay? And the best way to do this, I think, is to limit yourself to one page, 8.5 by 11 page, or whatever, the normal size page, that you put key terms, key processes, key concepts on. Okay? One point of having that kind of review sheet is that it is something you can be looking at 2:55 when you're waiting for me to get here with the exam, so for your own review. But the real value of that kind of study sheet does not come from looking at it after it's done. It comes from you making it. You deciding what is important enough to put on the sheet, what could be left off, you synthesizing things so that all of the techniques, all of the steps that we've learned this quarter get organized in your own mind. Okay? So don't think that just because I gave you a study sheet with key terms on and all of that, that you don't need to do something like that on your own. Okay? The process of you doing it yourself is really, really valuable. Okay. Other logistical thing is I will have the answers to the final exam study sheet up sometime tomorrow. Actually, if I can get to it today, I'll put them up today, but I would say tomorrow is the likely time for that. The answers to homework 6, same story. By the end of the day tomorrow, I'll have posted the lecture notes for this week, the answers for homework 6, and the answers for the study sheet. Okay. Any questions on logistics? No, we're organized there. Okay, so the two main things I want to do today, I want to go over re-emphasizing, and I hope maybe pull together a little bit, some questions that all fall under the topic of multiple equilibria. Okay, I don't think that's going to take too long, but I'll say something about this stuff, and then I'm going to go over that sample problem. Okay, so first of all, let me pick up and re-emphasize the point I was making at the end of lecture on Tuesday. Okay, and let me just summarize that point in terms of a basic fact. There are many equilibria. In the repeated prisoner's dilemma. Okay? Many, many, many. More than we can count. Okay? We specifically focused on mutual grim trigger, which is an equilibrium sometimes and not others. And let me just emphasize that sometimes and not others part. Sometimes, and the answer to when among sometimes mutual grim trigger is an equilibrium is that it depends on the player's discount factors. Okay? Depending on the particular payoffs in the particular repeated prisoner's dilemma, there's going to be some minimal discount factor, some minimal level of patience that both players will need to have in order for mutual grim trigger to be in equilibrium. Okay? Another thing, another equilibria in the repeated prisoner's dilemma is unconditional defection. Okay? This is the equilibrium, the only equilibrium in the single shot prisoner's dilemma. Okay? This is playing the dominant strategy in the stage game is always, no sometimes here, always a Nash equilibrium. Okay? There are others that we didn't talk about that you're not going to be responsible for finding on the exam, but I'll give you one example just to help you wrap your brain around the general point about what is and is not an equilibrium here. Another famous one that you may have encountered in other classes is tit for tat. Okay? Tit for tat is a different strategy than grim trigger. I'll put it up here. It says begin by cooperating, then do whatever your partner did last time. Okay? So that is a different strategy that if both players play it will be a Nash equilibrium sometimes in the grim trigger, and sometimes in the repeated prisoner's dilemma, excuse me. And just as with grim trigger, this is also a sometimes equilibrium, and again, it depends on the player's discount factors. Okay? Something we didn't cover this year, but you may have read about it in the book, is that the conditions for tit for tat to be in equilibrium are more strict than for grim trigger. Okay? If grim trigger is in equilibrium, tit for tat might be. Okay? But it's possible for grim trigger to be in equilibrium and tit for tat not to be. We didn't cover that, but it would be the same Nash equilibrium process there. Another thing to observe about this is that tit for tat, if it's being played in equilibrium, is going to look just like grim trigger. Okay? If either of these strategies is being played, all you're going to see is people cooperating. You're never going to see what would happen if somebody defected. It won't happen in equilibrium, so you would never be able to tell the difference. Okay? Among the other many other strategies that can be equilibria in a repeated prisoner's dilemma, there's lots of middle ground between these two. What's interesting about tit for tat is a strategy where off the equilibrium path, it's possible to make amends. Okay? With tit for tat, say I defect, you'll defect against me next time, but then if I cooperate, you'll start cooperating with me again. Okay, so tit for tat is a strategy that has lots of forgiveness. All you have to do is cooperate once, and you'll get us back on the equilibrium path. Okay? What makes tit for tat seem more appealing to many people, and what makes it a quote-unquote better outcome is if we step back from the prisoner's dilemma we're thinking about right now and think about a more realistic prisoner's dilemma where people can make mistakes, okay? I meant to cooperate, but oops, I didn't understand what cooperate meant to you, and I defected, okay? Or just something random happened, and you think I defected, but really I cooperated. Those kind of misunderstandings, if those occur in a world where people are playing mutual grim trigger, it's going to be bad, because sooner or later a mistake will happen, and we'll never be able to get back to the cooperating phase of the game. If what we're playing is tit for tat, and we're playing a prisoner's dilemma that allows for mistakes, allows for random error, then sometimes we will actually see people defecting by accident, or the defections will be misinterpretations. You can think about either of those things getting us out of cooperation, but we'll be able to get on back to the cooperative phase here. Okay? I'm not going to drift too far into the interesting facts about tit for tat. There are many of them, but I think I'm going to draw the line there. Okay. So my general point here, the reason why I'm emphasizing this so much is we need to bear in mind that there are multiple equilibria in the repeated prisoner's dilemma, because we can never say for sure that people are going to be able to cooperate. Okay? Even when the discount factors are high enough to support grim trigger, even when those discount factors are above the threshold value, it's still possible for another equilibrium to be focal, okay? We can be playing the repeated prisoner's dilemma. We can both be super duper patient enough that we could be cooperating, but if the fact is that I expect you to unconditionally defect and you expect me to unconditionally defect, that's going to be equilibrium. This is going to be mutually reinforcing. If you're playing this strategy, I don't do any better by deviating from it, okay? So when we're solving those repeated prisoner's dilemma problems and we're asking when can cooperation occur, we're asking when is it possible. We're never able to say it's guaranteed. We're never able to say it's guaranteed because there are multiple equilibria in this game, and the stage game equilibrium, unconditional defection, the Pareto inefficient outcome, that is always a possibility. Okay, so it's a very important caveat to to interpreting the happy side of grim trigger. Okay, it's never guaranteed. All right. Two smaller points here. Multiple equilibrium in the repeated prisoner's dilemma is just the same idea as multiple equilibrium in those single shot games. It means there's more than one pair of strategies that are mutually reinforcing. More than one pair of strategies where if you're playing your strategy, I don't do better than the strategy I have, and vice versa. Okay? So in single shot games, just to remind you, we looked at a number of single shot games that had multiple equilibria. One was Assurance. Okay? Assurance was the game that was like the prisoner's dilemma in that it had a defect-like equilibrium, but this game is different from the prisoner's dilemma in that in this game, just played once, both cooperating is also an equilibrium. Okay, so that was a single shot game in which there were two equilibria, one of which was Pareto efficient, the other of which was Pareto inefficient. Other games we talked about at different times in the course that had multiple equilibria were Battle of the Sexes, where there were two equilibria and one player preferred one of the equilibria, the other preferred the different one. Okay? So in Assurance, both players prefer the same Nash equilibrium. Okay, if we're given a choice, both of us would choose to be at the same equilibrium. In Battle of the Sexes, both players, or not both players, let me say each player prefers a different Nash equilibrium. Okay. So in the straightforward Battle of the Sexes story, the girl prefers the equilibrium where they both go to the ballet. The guy prefers the equilibrium where they both go to the ball game. Okay, that's what makes it Battle of the Sexes. Now, don't overinterpret what I'm saying about different players preferring different Nash equilibria. Okay, if I'm the girl and I think the ball game equilibrium is focal, okay, if that's what I think is going to happen, I'm going to go to the ball game. Yes, I'd prefer that we were in the world where both of us expected to go to the ballet. I would like that better, but I know that I can't change it. I know that the ball game equilibrium is focal. Okay? The other game that's very closely related to Battle of the Sexes is chicken. Okay? Really, the chicken has the same feature that each player prefers a different of the two Nash equilibria. I prefer the equilibrium where you swerve because I get to be the winner and tease you about it, and you prefer the other one because you want to tease me about being a chicken. The only difference between chicken and Battle of the Sexes is that in Battle of the Sexes, the partners want to do the same thing. They want to end up at the same place, and in chicken, they want to do different things. Okay? In chicken, we're out of equilibrium if we both swerve or we both go straight. Okay. Last thing I wanted to just repeat is the concept of focality and focal points. Okay? This is a weird concept because when we start talking about focal points, we are going outside the world of game theory. Okay? The idea of saying one of these equilibria is focal, what we're saying is that maybe the players do know that they both expect to go to the ball game. It's such a beautiful day. It's just got to be focal to go to the ball game. But we wouldn't know that from game theory. Okay? The game that you write down, what you have on your page, what you learn in PS30 is not going to tell you what is focal. It's going to get you up to the point where you can figure out what are the potential equilibria, whether you need to think about focality. But to know what is focal, the two things we turn to, outside of game theory, outside of the world of mathematical social science, is what we know about the history of the players and what we know about their culture. Okay? So if something is a focal point, it is the equilibrium. I'm just going to erase here to give myself a little more space. Among several that all players consider likely, obvious. It's what they expect. We don't always have focal points. Okay, you could be in a situation of multiple equilibria where nothing is focal as well. But in many cases, going outside of game theory in a particular context can help us identify which of several equilibria would be focal. All right. Yes?
Remember on the review sheet you mentioned that this is a term that we should know, but on the exam are we going to have to talk about focality?
I wouldn't. Elaine asked, on the exam, are you going to have to talk about focality? You guys know my exams well enough now that, I'm not going to, say, define focality, 2 points, that kind of thing. You are going to need to know the concept. Okay? You're going to need to know, in games that have multiple equilibria, you're going to need to know what you can and cannot predict in those cases. Okay? You'll lose points on the exam if, in the case of the repeated prisoner's dilemma, you're given a setup where the discount factors are high and Grimm triggers in equilibrium, you say something like, it's guaranteed these guys are going to cooperate. That's wrong. Okay? You need to understand that it's not guaranteed. So it's something you need to know how to apply, not so much. You need to know how to apply it to understand the limits of what you can say with game theory. The other thing that it would be completely unreasonable for me to ask you to do on the exam is to ask you in a particular question what you would expect to be focal. Okay? If this was a class about elections or crisis bargaining or something like that, where we'd learned a lot about the culture and history of a particular country, a particular part of the world, a particular phenomenon, then it would be fair game to actually ask you to use that kind of knowledge to talk about what's focal, but we haven't done that in this class. Okay. All right. Other questions on multiple equilibrium? All right. So what I want to do now is turn to that sample problem and start setting it up here. Okay, so I put together this problem because each of the scenarios in the problem does ask you to change the game in the way that I think most of you guys are, not most of you guys, but many of you guys are having problems with. Okay? And I think I want to preface this by reminding you of some things I said really early on when we first started doing game trees. Might have even been the first week of the course when I talked about the steps in setting up a game. Okay, and I had these three things that I was really emphasizing. Three things that when you're reading a scenario and it's kind of all over the place, it's got some relevant information mixed in with some irrelevant stuff, what you're reading at and what you're looking for while you're reading are the strategies, the preferences, okay, and the outcomes. Okay, the strategies are what can each player do, okay? What are their choices? Preferences are what do the players care about? What increases their utility? What decreases their utility? What do they regard as a good thing? What do they regard as a bad thing? Okay? We need these two things. Obviously, we need them when we're setting up a game because they're parts of the game. The strategies are either the labels on the branches, if it's a sequential game, or the labels on the rows and columns, if it's a simultaneous game. And the preferences are captured by the payoffs. Okay? So these are obvious that you can't have a game without these things. What's less obvious, but equally important, are the outcomes. Okay, and I want to remind you guys how important it is to take time to think about the outcomes. The outcomes are, I'll just write it, what links the choices of the players to the things they care about. If you really want to be precise, I would say the outcomes are the things that the players care about. What part of a scenario is an outcome? If either player cares about it, then it's part of the outcome. The preferences are the values assigned to those outcomes. Okay? What makes outcomes tricky in many of our questions, and certainly in reality, is that they often have multiple components. Okay? And that just sounds like life, right? What do players care about? Usually they care about more than one thing. That's what makes strategic situations interesting. You care about winning the election, but you don't like fundraising. Okay? You care about, in this scenario, blocking the hazardous waste center that's being blocked here. Yes, the waste treatment facility, but you don't want to be the one that does the work of fighting. Okay? So outcomes often have multiple components. Again, how many components are there to the outcome? As many as the players care about. If either player cares about it, it's relevant for the game, because if either player cares about it, it's going to affect their payoffs, it's going to affect what strategies they're willing to play in different situations. The whole idea behind putting numbers on payoffs, using numbers to represent payoffs, even though to represent how much people like something, even though it's very unrealistic, this is what allows us to compare multiple components of a situation. Okay? Those utility numbers that we've been using, synonymous with payoffs, those numbers are what allow us to compare multiple components of a situation. Allow us to compare apples to oranges. Again, touching base with some of the problem I started with the very first week of school. Allow us to balance the good that comes from a choice against the bad. We use numbers to represent how people balance competing parts of an outcome. Balance the good against the bad. All right. So here's my little speech about how important outcomes are. And I'm making this speech because I know for many of you are saying things to me like the hardest part of doing the homeworks is translating the story into a game. It just seems so confusing. Every week I get people who are just so sure that there's some critical part of the game that's not in the scenario, right? I know you left it out, Professor Bawn. No, it's there. You just got to look for it. Okay? And you're right. This is the hardest part. Translating the story in English into a game is one of the hardest parts. The other hard part is translating the game outcome into something about the story. So translating the world into game theory and translating game theory back into an observation about the world. It's the hard part. All the little calculations you guys are pretty comfortable with right now. How to find a mixed strategy equilibrium, what it means to be pure strategy equilibrium, how to solve a game with rollback, how to calculate expected values, how to find the equilibrium conditions in a repeated game. All of those mechanical things, they're very valuable, and it's important that you learn them. But this is also essential. Those calculation techniques don't get you anywhere unless you're able to translate the story into a game. Okay? The way to do this, though, is the same as the way we've approached the calculation steps. Do it one step at a time. Break it down. Be systematic. Okay? So what I'm going to do now is do at least some of that sample problem. I'm going to try and be as systematic and as explicit as I can about what the outcomes are in the game and how those outcomes translate into preferences. Okay? So with that, I'm going to start on scenario 2A, where we've got, what I'm going to do here is I'm actually going to read it. You guys follow along. I won't read it out loud, but I'm going to, as I'm scanning this, try to say out loud what I would be doing if I was writing the exam. Okay, so I'm reading County Environmental Commission, blah, blah, blah. Okay, the first thing that I'm looking for is who are the players. Okay, so I'm reading along, and by the second sentence I see, okay, we've got two players. It's the PTA and the Chamber of Commerce. Okay, good. And the things that I'm going to be looking for is what are the strategies, what can they do, and what do they care about? Okay, so I'm reading along, and I see if the facility is blocked, the utility of both groups will increase. Okay, so they care about blocking the facility. And right here, well, I'm noticing that that's what they care about. It's like right here in the same sentence. Both groups will get their utility increased by 8 units if the facility is blocked. So I'm going to put that plus 8 here. That's good. Okay? That's one thing they care about. But fighting the facility takes time and effort that could be spent pursuing other goals, blah, blah, blah. Okay, so the other thing they care about is the cost of fighting. They don't like that. It's a hassle. It's unpleasant. They'd rather be doing other things. If they have to fight, it's -5. Okay? So right here, here's my multiple components. Okay? There's two different parts of the scenario that they care about, and both of them raise or lower their utility by an amount that's given. Okay? Good. While I'm doing that, I'm also thinking, what are the choices these guys have? My sense is that you guys are pretty good about figuring out the choices, that few people are having trouble with that. In this case, it's fight and not fight. Okay. So right here, I've got my first two things. I've got my strategies, I've got my preferences, but in order to tie them together, I need to figure out the outcomes. I need to figure out what combinations of fighting and not fighting will activate these outcomes that raise or lower utility. Okay? So something I'm going to do that didn't actually occur to me till this week when I saw people were still having trouble with it, but it's not that different than what I was having you do with sequential games. Something you can do with simultaneous games is you can do a matrix of outcomes before you do the game matrix. Okay? So right here I'm going to do a matrix of outcomes. Okay? We're going to have the PTA here choosing fight or not fight. We're going to have the Chamber of Commerce here also choosing fight and not fight. And what I am doing here is precisely the analog of what I did at the beginning of class, at the beginning of the quarter, with remember our old incumbent challenger fundraising, not fundraising, not example. Remember the very first time I set this up, I wrote the outcomes at the bottom of the tree before I put the payoffs in, and I said that that would sort of help you. Okay? And what I wrote in here was who won the election. Okay? So it was the incumbent wins here, incumbent, challenger, incumbent. This is the step that sometimes you can do in your head, but if you're in an exam and you find yourself staring at that question and you're just not sure how to set up the game, do this step. Try to write it out. In the simultaneous world, a way to do it is just to make this matrix, and instead of going right to putting the payoffs here, let's use these cells to write what we think is going to happen. Okay? So here I do need to look at the scenario here. If they both fight, looking at the scenario, the center is going to be blocked, and they like that. They both pay the cost of fighting. Okay. In this first scenario, I'm looking at the third sentence from the end, the third and second sentences from the end. The third sentence that ends with both a comma and a period, that's charming. Okay, if neither group fights, the faculty will certainly be blocked. Okay, so here we know it's not blocked. No costs. Okay, but just continuing to read, if either or both groups fight, it will certainly be blocked. That's this scenario. That part changes with other ones. Okay, so on these diagonals, yes, the center is blocked. That's one of the things we care about. Okay, here, COC pays costs of fighting, the PTA doesn't. Here, it's blocked, PTA pays costs. Okay. So this matrix isn't a game matrix. A game matrix has to have payoffs, but it can help us set up the game matrix. Okay. If you wanted, we could just go ahead and try and put the payoffs here. I would not advise it. It does not take long to draw another matrix, and one of the issues with simultaneous games is when you're figuring out what's the equilibrium and what isn't, you have to remember which number to look at and which ones you're comparing it to. That's always an issue, and it's easier to get that right if you're looking at an uncluttered picture than if you're looking at a picture that's got a lot of stuff in it. Okay, so if it was me, would just write a new matrix here that is going to be the game matrix. Fight, not fight, PTA, COC. But I'm going to use what I've got here and what I've got in this part of the board. These are the notes that I would actually be writing down if I was solving that problem on an exam, and I'm going to put them together to figure out the payoffs. Okay? So here, when they both fight, yes, the facility is blocked. That gives us both an increase of 8. That we both fought, so we both lose 5. So we're both getting a payoff of 3. Okay? When you write down the things that they care about, it will often be the case that there's an implied baseline. Okay? The baseline was just implied in the way that the problem was set up. I continued to imply it here. What is the baseline case here? What happens in the baseline? What are these both relative to? Not fighting and not having the center blocked, right? Okay. If you don't have the center blocked, you don't get the plus 8. And if you don't fight, you don't get the minus 5. That's our 0. Okay. You don't subtract off 8 if the center is not blocked, okay? Because that would be saying that the value of blocking the center would actually be 16, okay? So it's just plus 8, switch colors, relative to the center not being blocked, okay? The center not being blocked has 0 effect. Blocking the facility gives you 8 more than what the center gives you. This is relative to not fighting. Okay. Now this game actually has a cell where the baseline outcome happens, okay, where neither player fights and where the facility is not blocked. So it has a cell with payoffs of 0, 0. That won't always happen, okay? Sometimes your baseline will appear nowhere in the game, okay? That everything that can happen will cause your utility to be increased or decreased relative to the natural baseline. Okay? It's also possible, we've had some homework problems where I don't ask you to add up the utilities. Sometimes the outcomes don't have this multiple component aspect. When I set up cops and robbers, for example, we weren't putting things together. Okay, so I'm just letting you know you don't always have to do that, but part of what you need to be able to do when you're reading those scenarios is figure out whether there are multiple components to the utility, and if so, how to put them together. Okay, so let's keep on. doing that. We've got these outcomes. Here, when the PTA doesn't fight and the Chamber of Commerce does, according to the setup, in this case, just the Chamber of Commerce fighting is enough to block the facility. Okay? So both of those guys are going to get the +8. I'm just going to put that here. Okay? And only the Chamber of Commerce is going to lose the 5. Okay? In this case, the PTA gets the benefits of having the center blocked. They didn't fight. They got to do other things, so their payoff is 8. Okay? Now, following my own advice, I'm not going to leave that as 8 minus 5. I'm going to really leave my simultaneous game in as pure a form as possible, again, because I want to really help myself focus in on the right information. I want to have that there as a 3. Okay? So I might, if this was an exam, write below that this was 8 minus 5. Okay? And it's going to be exactly the same here when the PTA fights and the Chamber of Commerce doesn't. The PTA gets the 8, loses the 5 for a net of 3, and the Chamber of Commerce gets the whole 8. Okay. That's setting up that game. Again, on the exam, that's going to take you some time. That's going to be a lot of work, and you shouldn't feel like you're doing something wrong if that's a lot of work. You should be at the point where, after you set it up, answering the rest of the questions is pretty straightforward. Okay? So, what is the question? Find all the Nash equilibria here. Okay. See any Nash equilibria? Where's one? Fight, not fight. That's a good one. Here's one. Is there another one? Right here. That's right. Okay. This game is chicken, the way it works out. Okay, it works out just like chicken, where fighting is the equivalent of swerving and not fighting is the equivalent of going straight. And you can actually imagine the leaders of these two groups having the kind of stand down that would look like chicken. What would it look like in reality? The Chamber of Commerce president really pounding the table about how important their other work is. I'm not going to fight, okay? My organization has too many other things to do, trying to make the PTA think that this is focal and vice versa. Okay? Are we done? We're not done. Okay? It didn't say find all pure strategy Nash equilibrium. It said find all the equilibrium. We might even remember that these coordination games, of which chicken is one, usually do have mixed strategy equilibria. Okay? So we've got to look for that as well. Even if we don't remember that, it's not going to affect your performance on the test to say this is chicken or not. It just, as I say, might help you organize it a little bit. But even if you don't remember that it's chicken, you know that you got to look for mixed strategy equilibria. Now, part of you might be remembering, oh, when there's a dominant strategy, then there aren't going to be any mixed strategy Nash equilibria, and that's true. Okay? Nobody has a dominant strategy here, though. That doesn't get us out of it. Okay? If I'm the PTA, if the Chamber of Commerce fights, I prefer not to fight. If they don't fight, I prefer to fight. So no dominant strategies. Again, that's making me think that I should look for the mixed strategy equilibrium. Okay, so looking for a mixed strategy equilibrium. What am I looking for? I'm looking for a probability. I'm going to say let P be the probability that the PTA fights. Okay, and I know how to find the value of P. If this P is in equilibrium, it's got to be the value that makes the Chamber of Commerce exactly indifferent between fighting and not fighting. Logic there is that if the PTA's probability of fighting gives the Chamber of Commerce a higher expected payoff from fighting, well, they're going to fight for sure. Okay? And vice versa. If it gives it a higher expected payoff for not fighting, they're going to not fight for sure. The only way the Chamber of Commerce is going to be willing to play a mixed strategy, the only way they're not going to have regrets from it, is if the expected utility from both of the pure strategies is the same. So let's look at that. not too hard in this game. The expected utility to the Chamber of Commerce of fighting, no uncertainty here. Okay? I fight, I'm going to get a payoff of 3. I fight in this story, my payoff is certain. I'm the Chamber of Commerce, my expected utility from not fighting. Here, the probability does affect my expected utility. Okay? With probability P, if I don't fight, I get that happy outcome of 8. I didn't have to do the fight, and the waste treatment plant went somewhere else. That's so good. I love getting 8, but that's only going to happen with probability P. Okay? And with probability 1 minus P, I get this outcome, which is 0. So that whole thing doesn't matter. Okay? So the value of P that makes COC indifferent between fight and non-fight is where 3 equals 8p, or p equals 3a's. Yeah, Tiffany.
Why didn't you do like 3p plus 3 times 1 minus 1?
You know, I could do that. Tiffany says, why didn't I just use the formula here? I get 3 with probability p, plus I get 3 with probability 1 minus p. Okay, if I do that, let's just keep going here. So that's 3p plus 3 minus 3p equals 3. So if you're going quickly and you don't notice the fact that the pairs are the same here, it doesn't take long to do this and you'll be just fine. Okay? So the nice thing about expected value, if we apply it in a case where we don't really need it, we still get the answer that makes sense and that is going to be right in context. Okay. So here we've basically found our mixed strategy equilibrium. We have to check whether we need to find a probability for the other player as well. Okay, equilibrium always has a probability for each player. So we do need to have a probability for each player. But in this case, because the payoffs are exactly symmetric, the Chamber of Commerce probability is going to be the same too. Okay? So let's say let Q equal the probability the Chamber of Commerce fights. Okay. We can say payoffs are symmetric. Therefore, Q also equals 3a's. Okay? It's okay to say that. You don't have to rederive the same thing. So, coming over here, there are 2 pure strategy Nash equilibria, not fight, fight, and fight, not fight. The mixed strategy Nash equilibrium is each player fights with probability 3/8, doesn't fight with probability 5/8. Okay. It would be fine to write this out as each player should be no less. It would be fine to write this out as PTA fights with probability 3/8, COC fights with probability 3/8. Okay. Yes, Elaine. No, this is not an answer for the mixed strategy equilibrium. Okay, one probability is not, just by itself is not enough. Okay, whenever I'm asking for an equilibrium, you have to let me know that you know that it's something for both players. Okay, is that what you were asking?
No, I was just saying, can you put MSNE dot P equals 3/8, Q equals 3/8, and that's sufficient?
Elena's saying, can we put P equals 3/8, Q equals 3/8? Would that be enough? It would be if you'd somewhere above said what P and Q are. Okay. Okay. My inclination now is not to do parts B and C for you guys, but to have you do them as part of your studying and to post the answers for that. Okay? I think that that's better for you. That one of the other persistent problems with poli-sci 30 is it makes so much sense when you're doing it at the board and then you guys do it on your own. So I will do that. Okay? Any other questions about this, about the exam? Okay, I'm going to leave you with one last piece of advice about the exam. Okay, and it's something, again, that I told you before the midterm, but remember it now. This is not an exam to stay up all night for. Okay, this is an exam to come in rested, fresh, have lunch, do 15 minutes of yoga beforehand, go for a run, whatever it takes. You guys have done most of the learning that you need to now. If you haven't done it, it's probably not going to happen. If you don't get mixed strategies right now, you're probably not going to get it in a week. Okay, but what you want to do now is over the weekend, solidify your skills, work on the practice, and then come in sharp enough and calm enough that you're going to be able to do this systematically. Okay? So with that, I think you're going to do a good job.